Welcome back, dear students. So in today's session of integration, we are going to see integral of some trigonometric functions again. Okay, so it's the continuation of integration of trigonometric functions. Okay, so for the first kind of integral that we are going to deal today is on the screen. So today first we are going to see the integration of this kind. Okay, now if you see here, we have got a power to be n, and this n is a positive integers, or in other way you can call it n to be a natural number. Okay, so positive integers and natural numbers both are same. Now there are two conditions possible. One is n can be odd, so in that case you have to do the substitution, that is cos x equals to z. Okay, now when n is even, then you have to express the integrand. Integrand is this. Okay, we have to express the integrand in terms of multiple angles. All right, so let's see. So let's begin with the example for today. So the first example I'm taking for you is so evaluate this integral. So integral is I equals to, so let me put odd here. Okay, so let me make it sine to the power 5x dx. Okay, now question says, or the rule says that put cos x equals to z, isn't it? So if I do that, then we get, see here carefully, so let cos x is equals to z. So if I do that, then we have to differentiate, so we get minus sine x dx is equals to dz. That is, sine x dx can be written as dz. I'm sorry, minus dz. Now see here carefully, can I write this integral as integral sine to the, okay, sine square x whole square into sine x dx. Can I do that? Yes, I can do that, isn't it? Okay, so we know that sine x dx is minus dz. Okay, now can I write this as 1 minus cos square x whole square? Yes, and we have into sine x dx. So whenever you have odd power, you have to go in this way only. Okay, so therefore your integral I will change into, okay, so we have integral 1 minus cos x is z, right? So that's why cos square x becomes z square whole square. Okay, whole square is also there. Sin x dx is how much? It is minus dz. So minus can be kept outside integral sign, so you have this one. Now it's very simple, isn't it? So you have a minus b whole square. So let's apply the formula. So it is integral, so this is a square minus 2ab, b is z square, and b square is z square whole square, and that becomes z to the power 4 dz, isn't it? Now let's separate all these integrals. So this can be written as integral 1 square is 1, so we get only dz, minus into minus becomes plus, so 2 is a constant, can be kept outside integral sign. So this is z square dz plus, I'm sorry, this is minus into plus going to be minus, so integral of z to the power 5 dz. Okay, as the work is very simple now, see, this is equal to, this is minus z plus 2 into, this is z cube by 3, yes, minus this is z to the power 6 by 6 with a constant of integration. Now ultimately let's resubstitute the value of z. So z is cos x, so this becomes minus cos x, okay, plus 2 by 3, okay, so 2 by 3 z cube, that is cos cube x minus 1 by 6 z to the power 6, that is cos to the power 6 x with a constant of integration. So this is your answer for this particular question. Okay, now you may pause the video and note it down, so that we'll see the next case when n becomes even. Okay, so here we have the power of sine to be even. Now if you look at the rule, it says express the integrand in terms of multiple angles. Now all of you know that integrand is this, isn't it? So you need to express this sine to the power 4x as multiple angles. Now multiple angles means we have got sine 2 theta, we have got sine 3 theta. Okay, so it's called multiple angles. 2 theta, 3 theta, all these are called multiple angles. Okay, so whenever you see this, first and foremost, express this as sine square x. For that you have to put whole square outside. Okay, now you know one formula. We have got one formula which says 2 sine square theta is equals to 1 minus cos 2 theta. Yes, so we have got this formula. This is called your multiple angle. Okay, because sine square theta can be written as this. Okay, so if you take this 2 to the denominator, we get this formula. Okay, so this is called your multiple angle. So let's apply this then. So we get sine square theta is, that sine square x is 1 minus cos 2x by 2 whole square. Okay, fine. So this becomes, so 1 by 4 it's there. Okay, so this a minus b whole square, so becomes 1 minus 2 cos 2x plus cos square 2x. Okay, so this is the thing. Now again we have got cos square 2x, isn't it? Okay, so if you want to see, in fact we have to change this, don't worry. So we will write cos square theta as 1 plus cos 2 theta by 2. This is another formula, that's for cos square. Okay, so the same rule is there with cos also. Whatever we are doing with sine, the same rule happens with cos also. So in that case I need to express this as this. Okay, so if I do that, then I can write this as 1 by 4 1 minus 2 cos 2x plus, so as I said, cos square 2x can be written as 1 plus cos 4 theta this time, because we have got 2x, and this, when it changes to double, theta changes to double, so becomes 2 theta. 2x changes to double and becomes 4x divided by 2. Okay, so this is the formula. Okay, so let's simplify this further. So we have 1 by 4, so you can write this as, okay, so 2 is the LCM, so 2 into 1 is 2, minus 4 cos 2x plus 1 plus cos 4x, isn't it? So this is how much? This is 1 by 8. So we have 2 minus 4 cos, I'm sorry, this is 2 plus 1 is 3. So 3 minus 4 cos 2x plus cos 4x, right? Okay, so this is your sine to the power 4x. Okay, so we have expressed this in multiple angles. Now integral I changes to, see here carefully, so instead of this sine to the power 4x, I am writing this entire thing. 1 by 8 can be kept outside, so this can be written as integral of, okay, so we have 3 dx minus 4 can be kept outside, so integral of cos 2x dx plus we have integral of cos 4x dx. Okay, now the work is very simple, isn't it? So this becomes, so let me write it over here, equals to 1 by 8 is anyway outside. Okay, okay, so this is 3 can be kept outside integral sign, so 3 integral dx is just 3x, remember that, minus 4. Okay, now integral of cos mx is, you know that is 1 by m, m is how much? 2, and integral of cos becomes sin mx. Okay, so m is 2, remember that, plus similarly we have integral of cos mx will be 1 by m sin mx, that is 4x. Okay, now put a constant of integration, do the cancellation. So we have, ultimately my answer is 1 by 8 3x minus 2 sin 2x plus 1 by 4 sin 4x. Okay, so we are done with the problem. Okay, so I hope you have understood what happens, or in fact what we need to do when the power is odd and even. Okay, so if you have understood this, we'll close for this kind of particular integral. Now we'll move on to another very important kind of integral. Okay, so here in front of you we have another form of integral, but this time we have cos, and as I said earlier, rule is same. So when it was sine, you substituted cos x equal to z when n is odd. Okay, and when n is even, the rule stays the same. Okay, so let me take, this is my question number 3, right? So question number 3, so let's evaluate this integral. So let me take cos to the power 7x for you. Okay, now as the rule says, put sin x equals to z, and before that, all of you know that we will write this as cos square x whole cube into cos x dx, and this in turn can be written as 1 minus sin square x whole cube into cos x dx. All of you know this, right? Okay, so now let's do the substitution, and the substitution that we make here is sin x equals to z. Okay, so let sin x is equals to z, so this will give you cos x dx is equals to dz. So therefore your integral I will change into, look here carefully, so this becomes 1 minus sin square x becomes z square whole cube into cos x dx is dz, right? So this can be written as, okay, so let me leave it half for you, you will complete by yourself. Okay, so this becomes this is your a minus b whole cube, isn't it? So put formula for a minus b whole cube, you will get 1 minus 3z square plus 3z to the power 4 minus z to the power 6 dz. After that, do the integration. So ultimately your answer, okay, so you have to do some incomplete steps out here. Okay, so you have ultimately your answer turns out to be sin x minus sin cube x plus 3 by 5 sin to the power 5x minus 1 by 7 sin to the power 7x with a constant of integration. Okay, so you may pause the video and note it down. Okay, now let's have a look at this particular problem. So as you all know, as the power is 6, which is even, we need to express the integrand in terms of multiple angles. So we have cos to the power 6x can be written as cos square x whole cube, and I have already given you the formula, right? So we have cos square theta equals to 1 plus cos 2 theta by 2 whole cube, right? Okay, so this becomes, see here carefully, this is 1 plus a plus b whole cube, so this becomes, okay, so in the denominator we get 8, right? So when you put a plus b whole cube formula, you have to get a cube plus 3a square b, that is cos 2x plus 3ab square, that is 3 cos square 2x plus cos cube 2x, right? Okay, so this can be written as, okay, so again you have to go to your class 11 formula, trigonometric formula, and see what are the respective formula. So we have 1 by 8, 1 plus, okay, so I'm leaving this as it is, we don't have to do anything out here because the power here is this one. So you know what we did when we had cos square kind of stuff earlier? Yes, so we made it, or rather we changed it into again the same kind of thing, isn't it? That is, we changed this using this formula only. Okay, so this becomes, so we have 3, okay, so cos square 2x can be written as 1 plus cos 4x by how much? 2, right? I'm using this formula only. Cos square x is 1 plus cos 2x divided by 2. I'm using that formula only. Now we have here cos cube 2x. Now if you have if you refer your triple angle formula, that is cos 3 theta, 3 theta. Okay, so the formula from that gives you 4 cos cube theta minus 3 cos theta. So this is the formula. Okay, now if you find cos cube theta from here, just wait a minute, cos 3 theta is cos cube theta, yeah, it's okay. So this is the formula. So if you find what is cos cube theta from here, you have to take this out there, isn't it? So from here you get cos cube theta will be equals to 1 by 4 cos 3 theta plus 3 cos theta. So this is the formula that you arrive at from this particular formula. Okay, so I'm going to make use of this formula here. So if I do that, see here carefully. So cos cube theta can be written as 1 by 4, okay, cos 3 theta, isn't it? And what is theta? Theta is 2x. So that's why it becomes 3 into 2x is 6x plus 3 cos theta, and theta is 2x, right? So we get, so this becomes 1 by 8. So 1 plus 3 cos 2x plus, okay, so this is 3 by 2 plus 3 by 2 cos 4x. Okay, this one becomes this much. So similarly this becomes plus 1 by 4 cos 6x plus 3 by 4 cos 2x, right? Okay, so 3 by 4 cos 2x. Let's close the bracket. So we get 1 by 8. So we have a cos 2x. Here also we have a cos 2x. So if you want to keep them together, that will be better. So 1 plus, so we have 3 plus 3 by 4 will be how much? 3 into 4 is 12. 12 plus 3 is 15 by 4 cos 2x. Okay, and so here we have got 3 by 2 plus 1. So 2 ones are 2 plus 3. It is 5 by 2. Okay, so constant term is 5 by 2. So we have cos 2x. Now cos 4x is 3 by 2 cos 4x plus ultimately we have 1 by 4 cos 6x. Okay, so we have expressed this integrand in terms of multiple angles, as you can clearly see, right? Now apply the integral. So your integral I will change into, so first is 1 by 8 is kept constant. Okay, so this becomes, for the first one, 5 by 2 is also constant, so it becomes just dx plus 15 by 4 integral cos 2x dx plus 3 by 2 is outside, so integral cos 4x dx plus we have got 1 by 4 also integral cos 6x dx. Okay, now your turn is to evaluate this, and ultimately your answer will turn out to be, okay, so do the remaining part. So your answer will turn out to be 1 by 32. So 10x plus 15 by 2 sine 2x plus 3 by 2 sine 4x plus 1 by 6 sine 6x, with a constant of integration. That will be your answer. So you may pause the video and note it down. Okay, so on the screen you have integral of the form integral sine to the power mx cos to the power nx dx. Now if you look at the rule, there are 3 different cases out there. Okay, so the first case says when at least one of the exponent means m or n, is positive odd integer no matter what the other may be. Okay, for instance, when m is odd, see, out of m and n you must have only one as odd. For example, when m is odd, that time you have to put cos x equals to z. Now when n is odd, that time you have to put sin x equals to z. So that is the first case. Okay, second case says when both the exponents are positive or even integers this time, that is both m and n are positive even integers. Alright, then express the integrand in terms of multiple angles. Okay, that's very easy for you. Next is, when m plus n is a negative even integer, that time you have to put tan x is equals to z. Okay, so I hope the rule is clear to you. So if it is clear to you, let's begin with the sums based on this particular type of integral. Okay, so on the screen you have the first question. So as you all know, the sine root over sine x can be written as, it can be written as integral of sine to the power half x, right, cos to the power 5x dx. Now if you compare this with sine to the power mx cos to the power nx, it falls under the first category. You know why? Because any one of them has to be odd. That's what the first rule says, right? So we see that n, this is m, remember, sine to the power mx cos to the power nx. So it is said, if n is odd, okay, first and foremost any one of them has to be odd. So we see that only this is odd, n is odd. So when n is odd, the rule says put sine x equals to z. Okay, so let's do that. So let me call this to be integral I. So let sine x is equals to z. So this will give you cos x dx equals to dz, right? So in fact this can be written as sine to the power half x cos to the power 4 x into cos x dx, right? And you know that this can be written as sine to the power half x, and this can be written as 1 minus sine square x whole square cos x dx, right? So in that case this integral, this particular integral will change into, therefore your I will become integral, okay, sine x is z, so that's why this becomes z to the power half 1 minus sine square x is z square, whole square is also there, cos x dx is how much? It is dz. Now apply the formula again, so it is z to the power half, so this is a minus b whole square, and it becomes a square minus 2ab plus b square. Okay, now open up the bracket, so this becomes z to the power half into z to the power half into 1 is z to the power half dz, minus 2 can be kept outside, so z to the power half plus 2 is 5 by 2 dz, yes, plus integral z to the power half plus 4 is z to the power 9 by 2 dz. Alright, now your integral is very easy, isn't it? Okay, so do the rest part. Okay, I'll give you the final answer. It will turn to be 2 by 3 sine to the power 3 by 2 x minus 4 by 7 sine to the power 7 by 2 x plus, you'll have 2 by 11 sine inverse, sine to the power 11 by 2x with a constant of integration. This will be your final answer. So we have yet another question. So I have directly given you the answer. I'll just do the half part here. Okay, so the question says that it is sine square x plus cos to the power 4x dx. So your value for m will be 2. This is my m and this is my n. Okay, so this falls under your rule number 2, which says if both the exponents are positive even integers, express the integrands in terms of multiple angles. That's what the rule says, isn't it? So if that is the rule, let's begin. So we have sine square x cos to the power 4x. Now sine square x, we don't have any problem with this, right? So sine square x, and this cos to the power 4 can be written as cos square x whole square, right? Okay, so your work is easy now. So you know that this is 1 minus cos 2x by 2, right? And this is 1 plus cos 2x by 2 whole square. Okay, fine. Okay, so what you can do here is you can write this as 1 by 8. See here carefully. So you can write this as 1 by 8. Now can I write this as 1 minus cos 2x into 1 plus cos 2x into 1 plus cos 2x? Can I do that? Yes, I can do that also, right? So all of you know that this is 1 by 8. So this a minus b into a plus b, which gives you a square minus b square, that is cos square 2x, and we have 1 plus cos 2x with us. Okay, so we have 1 by 8. Okay, so this becomes sine square, how much? Sine square 2x, okay, into 1 plus cos 2x. Now again you can write this sine square x as 1 minus cos, double of this is 4x, by 2 into 1 plus cos 2x, right? Okay, so we have 1 by 16 then. So 1 by 16. Okay, so we have 1 into 1 is 1. 1 into cos 2x is cos 2x, minus cos 4x into 1 is cos 4x, plus minus into plus is minus, so cos 4x cos 2x. Okay, now there is one more formula from trigonometry which says, okay, so let me write the formula for you. So cos a cos b is equals to, remember it is half of cos a plus b plus cos a minus b. Okay, so if I use that formula, this becomes, see here carefully, this is 1 by 16, 1 plus cos 2x minus cos 4x minus, okay, so this is my a, 4x is my a, b is 2x, so this becomes half. Okay, let me open the bracket also. Okay, so cos a plus b becomes cos 4x plus 2x is 6x, okay, minus, okay, because we have got minus here, so minus into plus becomes minus, so half is also there. So cos a minus b, that is 4x minus 2x is just 2x, right? So it is cos 2x. Okay, now your work is very easy, you know. Let me write your final thing out here. So this becomes, the next step is 1 by 16. Okay, so 1 is left as it is. Cos 2x, here we have minus half cos 2x. So altogether this becomes half cos 2x. Okay, we have minus cos 4x minus half cos 6x. Okay, so I have done my part. I have expressed this as multiple angles. See, I have expressed this integrand as multiple angles. Now your job is to apply the integral and arrive at this. So you may pause the video and note it down. So dear students, in front of you we have another question. Now this question falls under your rule number 3, because here this integral can be written as integral of sine to the power minus half x cos to the power minus 7 by 2 x dx. Okay, so this is your m and this is your n. So add them, you will always get a negative even integer. Why? Let's see. Because minus half minus 7 by 2 will always give you minus 4. Now it is negative, that's okay, and on top of that it is even also, because we have got a number 4, right? So in this case the rule says that put tan x equals to z. So let's do that. So let tan x is equals to z. Okay, so if this is my z, then from here we get sec square x dx is equals to dz. All right, so if this is your integral I, therefore you can write your integral I to be, see here carefully. Okay, so I just reduced this in order to show that what is m and what is n. Okay, so let's keep it as it is like before. So if you write this as dx by, okay, so this sine to the power half x cos to the power 7 by 2 x. Okay, now see here carefully. What you can do here is okay, let's try to see what is cos to the power 7 by 2. What is cos to the power 7 by 2? 7 by 2 means it is 3.5, right? Okay, so it is 3.5. So we'll take the reciprocal of cos. You know that reciprocal of cos is sec, and we'll take the power slightly more than 7 by 2, that is 3.5, and slightly more than means it is sec to the power 4, isn't it? So let's do that. So let's multiply both numerator and denominator by sec to the power 4x. I hope this thing is clear to you, because I want to get sec square. Okay, fine. Okay, so this can be written as, so all of you know this sec square, sec to the power 4 can be written as sec square x into sec square x dx divided by, okay, so we have sine to the power half x. Okay, now this cos to the power 7 by 2x. Now this sec to the power 4 can be written as cos to the power 4x in the denominator, because this is the reciprocal, isn't it? Reciprocal of cos can be written as 1 by cos to the power 4x. Okay, so we have, so sec square can be written, this sec square can be written as 1 plus tan square x. Okay, fine. And into we have again sec square x dx with us. Now this is sine to the power half x. Okay, and as I said, this is your 3 by 2, isn't it? So let me take this to the denominator, so it becomes cos to the power, okay, so let me write it cos x, so power is 4 here, so this becomes minus 7 by 2. Okay, so this is equal to, so this is equal to, see here carefully, so 1 plus tan square x into sec square x dx divided by, so this is sine to the power half, we already have that, have this sine to the power half x is already there. Now what is this? Okay, so 4 to the 8, 8 minus 7 is 1, so this becomes cos to the power half x. Okay, so what is this? This is 1 plus tan square x into sec square x dx by, this is sine by cos, both has got the same power, so that's why this becomes tan to the power half x. Now let's do the substitution. Now 1 plus tan x is z, so that's why this becomes z square, sec square x dx, this is dz by tan x is half, tan x is z, so this becomes z to the power half. So split the integral, this becomes z to the power minus half dz plus integral z to the power 3 by 2. Okay, 2 minus half becomes 3 by 2 dz. So evaluate this integral and substitute the value of tan. Okay, so when you evaluate this, this will turn into 2 z to the power half. Okay, plus similarly when you simplify this, this will turn into 2 by 5 tan to the, I'm sorry, z to the power 5 by 2. Now put a constant of integration, now put the value of z. So this is, z is tan x, isn't it? So this becomes tan to the power half x plus 2 by 5 tan to the power, similarly this becomes 5 by 2 x with a constant of integration. So you may pause the video and note it down. So we have yet another rule, and in this case you are going to deal with the integrals of kind tan to the power nx, okay, or cot to the power nx. So as you clearly see that the rule says we have to write tan to the power nx as tan to the power n minus 2 into tan to the power 2x, right? So you have to write in that way, and as you can clearly see, if you take out, or rather if you write tan square x in terms of sec, it becomes sec square x minus 1. And the same thing happens with cot as well, as you can clearly see on the screen right now. Okay, so if you have understood the rule, let's see this problem. Okay, so we have this one, right? So the rule says this is your n, right? So write this as tan to the power n minus 2, that is 4 minus 2 is 2, into, you'll write this as tan square x dx. Okay, so this can be written as, so tan square x, now this can be written as sec square x minus 1. It is already given this part, right? Now what you can do here is you have to open up the bracket. Okay, so if you do that, you get tan square x sec square x dx, right, minus tan square x dx. So this is the integral that you arrive at. Okay, now if you see this, this is integration by substitution. You have to take the substitution, tan x equals to z. Okay, and this can be written as, again, this tan square is there, right? So this tan square can be written as, okay, so let me do it for you. So this sec square x into tan square x, I'm sorry, so let me write it this way, tan square x minus, now this can be written as, again, sec square x minus 1 dx. Okay, so see, this has to be done after the split here. Okay, so after we split this single integral into two integrals, then only again you will apply this formula. Okay, fine. So as I said, so let me do the substitution part here also. So let tan x is equals to z. So this will give you sec square x dx equals to dz, right? So if I do that, this integral, see, sec square x dx is dz and tan x is z, so that's why this integral will change into z square dz minus, now this is integral of sec square x dx, minus into minus becomes plus, so it is integral dx. Now it is z to the power 3 by 3 minus this integral of sec square is just tan x plus this is x, put a constant of integration, so 1 by 3, z is tan x, so that's why this becomes tan cube x minus tan x plus x with a constant of integration. So you may pause the video and note it down. Okay, so this time if you look at this problem, there is a power given to be odd, but we don't bother whether this is even or odd in case of tan and cot. The only rule we need to follow here is, if this is your integral I, we have to write this as cot to the power n minus 2, that is 3 minus 2 is just 1, so need not write that. So we have into cot square x dx, and as you know, this can be written as, so cot square x can be written as cosec square x minus 1 dx. Okay, now split the integral, you'll get cot x into cosec square x dx minus integral of cot x dx. Okay, now the rule is same, so here we will do integration using substitution. So let cot x is z, so this will give you minus cosec square x dx is equals to dz, that is cosec square x dx will turn out to be negative of dz. So that's why, see, cot x is z, so that's why this integral will change into, this is negative of dz, right? So negative of dz, so negative sign is kept outside, so cot x is z. Okay, so this is integral z dz. Now all of you know that integral of cot x is log sin x. Okay, so this is the formula. Now okay, let me not put the constant of integration now. So this is minus half z square minus log sin x. Now you can put a constant of integration because you are done with the integration here. So minus half, now what is z? Z is cot, so that's why this becomes cot square z minus log, I'm sorry, cot square x, I'm so sorry, this is cot square x log sin x with a constant of integration. So this is your answer for this particular question. Okay, so we have yet another, and in fact this is the last part of the indefinite integral. Okay, so this is the integral of the form sec to the power nx and cosec to the power nx. So there are two cases here again. Okay, so when n is even, then the rule is clearly given to you. Okay, so when n is odd, you have to integrate by parts. Okay, so you have to keep that in mind. So whenever you see n to be odd, you have to integrate it by using integration by parts. Okay, okay, so let's observe this. Now see, you don't bother whether this is cosec or sec. Only thing that you need to bother is about the power, and here you see that the power is even. So in this case, again as usual, in earlier problem also we did the same. So this can be written as cosec. Now this n, this power has to be written as n minus 2, that is n minus 2 becomes 6x, and we can write this as cosec square x dx, right? Now you know that cosec square x can be written, okay, so let's not change this. So this can be written as, this one can be written as this can be written as cosec square x to the power 3, yes, into cosec square x dx. Can I do that? Yes, this is also allowed. Now we know that cosec square theta can be written as 1 plus cot square theta. So let me write this as 1 plus cot square theta and cube into cosec square x dx is there, right? Okay, so we can put the substitution out here, I guess. So let me make the substitution. Let cot x is equals to z. So differentiate it, you get minus cosec square x dx will be dz. That is, you will get cosec square x dx is equals to minus dz. So in this case your integral will change into, so this is negative dz, so negative is outside. So this is 1 plus cot x is z, so that's why this is z square, and outside we have got whole cube, so we get this one. Now the rule is simple, isn't it? So again apply the formula a plus b whole cube, that will give you 1 plus 3 z square plus 3 z to the power 4 plus z to the power 6 dz. Okay, so complete it by yourself. The integral part is very simple. I'll give you the final answer. Okay, so do some parts, missing part. So your answer will turn out to be negative of cot x plus cot cube x plus 3 by 5 cot to the power 5x, and ultimately you have plus 1 by 7 cot to the power 7x. Now put a constant of integration. So this is your answer for this particular question. Okay, so let's have a look at the last question from the indefinite integrals. So this falls under your second category, which says if n is odd, that is the power is odd, then integrate by parts. Okay, so when you integrate using part, you follow this rule, right? Okay, so this falls under trigonometric category. Okay, and we don't see any second function. Now you might treat another function to be 1, but please do not do that. Okay, so I'll give you the hint for you. Okay, so how to proceed. Now no matter what do you have, whether you have to the power 5 to the power 7 or what you have to do here is you will write this as, first write sec square x and write down the leftover. So here we get the leftover to be sec x dx. Okay, so all of you know that the one which comes first, the first function will be differentiated, yes, and the second function will be integrated. Okay, so whenever you get sec square, you will always treat this as second function, and the remaining one will be treated as the first function. That's the only thing that I can say here. Okay, so that's the only hint. Okay, so if this is your first function, then this will remain outside. We have to integrate the second function, that is sec square x dx, right? Now integral derivative of first function. So what is first function? It is sec x, integral of sec square x dx, and we have dx also, right? Now we have sec x. Now integral of sec square x is tan x. I'm sorry, minus is also there, minus integral. Now derivative of sec x is sec x tan x, remember? So this is sec x tan x, and integral of sec square x is tan x. We have got integral, I'm sorry, we have got dx also, right? Okay, so what can be done now? So we have here tan square x, right? So let me write this as in sec x tan x minus, so we have sec x into, this is tan square x, right? This is tan square x, can be written as sec square x minus 1, isn't it? Yes. Okay, so in that case this becomes sec x tan x minus, so open up the bracket, you get integral of sec cube x dx plus minus into minus is plus integral sec x dx. Okay, now see here carefully, this is sec x tan x. Now isn't it the same thing? So can I write this as I? Okay, now all of you know that integral of sec x is how much? It is log of sec x plus tan x. Okay, now as we are done with the integral, we'll put a constant of integration. We'll take this to the left hand side. We have got I, remember this is I. Okay, so this is I, here also we have got I, here also we have got I. Okay, so when you bring this here, you will get I plus I, which is 2I. So this becomes sec x. Okay, so let's not put this now. So we get sec x tan x plus log of sec x plus tan x, right? Now our aim is to find I, but here it is 2I. So therefore your integral I will be, take this half over there. So this becomes half sec x tan x plus log of sec x plus tan x. Okay, now you may put the constant of integration at last. So this is how we do this kind of sum. I hope today's lecture was easy. So practice more sums, refer to the questions attached so that you will get familiarized with the process on integration. So with this we close definite integrals. From the next class we will begin with, we'll close with indefinite integrals. In the next class we will begin with the definite integrals. With this we close. Thank you very much.